Okay, we're on problem 25, and they want us to use the product rule on it. So this is big F of x equals, and it's a product, which is x squared plus 5 times, they're emphasizing the product, by the way, 4x minus 2, right? Now, one thing that's about the product rule is commutative, so you can any order you want, but I'll put this over here for you. And I'll kind of write down, at least initially, be somewhat careful about it. So the first function times the derivative, I'll put a little mark there, I'll do that in a moment, plus the derivative of the first function times the second function. All right, and maybe being too careful can hurt you, actually. What's that going to be? Well, the derivative of 4x minus 2 is just 4, plus, well, the derivative of x squared plus 5 is 2x, and they get 4x minus 2. Now, for some teachers, that's a good answer. I want to simplify it, though. And as I'm doing that, that's 4x squared plus 20 plus 8x squared minus 4x. What do you get over here? 12x squared, 4 and 8 is 12, minus 4x plus 20. All right, we'll go to the next question. Again, we're doing the product rule. So that was question number 20. I'm on 26 now. 26, a big F. And they got this over here, minus 3x to the 7 plus 5x cubed, and then it's multiplied by x9 minus 200. Right, I'm not going to be so careful like the last time with all those prime marks. The first function times the second function plus the derivative of the first function times the second function. Again, for a lot of instructors, that's a fine answer. I don't find anything wrong with that, by the way, but I do want to go through working it out, by the way. A little tedious, but we can do that. And to multiply this out, what do you get? Let's see, minus 27. X, 8 and 7 is going to be 15. Then you're going to get plus 45, x to the 11. That's going to be more difficult, this one over here. Let's do it. So it's minus 21, x to the 15. And then minus times a minus a plus. And that's 21 times 200. All right? That doesn't look bad. I'll write this way over here. If you did that, I hope you realize you get 4,200. All right? I'll put this over here. 4,200 x to the 6. Let's keep going. Plus 15x to the 11, and then minus, let's see, it's 3,000, right? All right, I'm going to look through it, and the way I like to do it, I like to look at the highest degree variable first. So I'm going to say this guy here and this guy here, and I got to combine those two together. What would that give you? Minus, let's see, 48. All right, let's move down the food chain. What's the next thing I'm seeing? I'm seeing these two terms. They're 11s, right? What do you get there? 60. Then what do you get? Well, the last two terms, 4,200 x6 minus 3,000 x squared. A box in that. Now, one thing nice about this particular worksheet that this guy, Black Pen, Red Pen, his name is Steve Chow, he shared the answer key with us. So I'm going to look at it. And I always say if something gets complicated, I want to look at the key. I'm seeing this. I'm seeing this. I'm seeing this. And I'm seeing this. And I feel good about that. All right. Now, number 27, against product rule, is f of x equals x times the root of x plus 3. And again, a little better at this. F prime. I'm going to say the first function times the derivative of the second function. And I've been differentiating roots now for a while, and so have you, our 27th problem. There's going to be 1 over 2 root x. The derivative of 3 is 0. Plus the derivative of the first function, which is 1, times the second function. Again, I'm of the opinion that's a good looking answer, but I do want to rewrite it. And what would you get over here? You get 1/2 root x plus root x plus 3. I'm going to add that together, and what do you get there? Well, 1/2 and 1 is 3/2 of a root x plus 3. This should be a deja vu for you. We did that problem prior. And do we get the same answer? We get the same answer. I don't think I'd use product rule on that, but anyway, we're asked to do it. We did the product rule. All right, let's do 28. And 28, you're seeing this big F again. And then you're seeing x to the 5th power times the sine of x. Let's write this down, f prime. I can say the derivative of the first function, which is 5x4, times the second function, plus the first function, times the derivative of the second function. The derivative of sine is cosine. Let's clean it up a little bit. Actually, there's nothing to clean up right over here. Let's just take a look at the key. Always say, if you give the key, you might as well just look at it. I want to put on a key. The order in which you do the product rule doesn't matter because additions are commutative. So am I seeing what I'm supposed to see? Let's take a look. I'm seeing 5x4 sine x. That's the second term. I'm seeing x5 cosine x. Things are looking good. Let's go to problem number 29. And 29 is a product of two functions. It's sine x times the cosine of x. F prime, I can use the product rule. That's what it has to do. I'm going to say the first function this time times the derivative of the second function, which is minus sine x, plus the derivative of the first function, which is cosine x, times the second function, which is cosine x. What do you get here? Minus sine squared x plus cosine squared x. I want to write that a little differently. It's cosine squared x minus sine squared x. Little box in it. Again, I do recommend looking at the key, by the way, and I do see that. Before I go on, I want to point out that you should be aware of some identities. For example, the sine of 2x is 2 sine x cosine x. That's one you should be familiar with. And you should be aware of the cosine of 2x as well. That's got 3 different identities. But cosine squared x minus sine squared x, that's one of them. So this is also equal to the cosine of 2x. All right? 29, let's go on to 30. 30 is e to the x. I'm sorry, it's big F of x is e to the x times the tangent. Again, if you can't remember the derivative of tangent, you'd have to derive that, but hopefully it's fresh in your mind from class or from study. So I'm going to say the first function times the derivative of the second function, which is secant squared, plus the first function, which is e to the x, times the second function, which is tan x. Not much you can do about that, except possibly factor it. And by the way, he did factor it. I'll write that down for you. E to the x, that would be secant squared plus tangent. All right, and let's go to the next one, which is 31. And 31 is big F. And this is going to be x cubed. And then there's a root of x plus 1. Or a little differently, I'm writing it as x cubed times x plus 1 to the 1/2 power. Let's write the derivative down. The derivative of the first function times the second function plus the first function times the derivative of the second function. Let's clean it up a little bit, and I'll rewrite it so there's roots in the problem. 3x squared, the root of x plus 1. This is going to be plus, I'm going to see x cubed, I see a 2, and I see the square root of x plus 1. A little box in this over here. Okay, I'm going to look at the answer key, and this is problem number 31. I realize his work, it's good he put work down in this problem over here. And let's see what he's got over here. And I noticed his answer, his first answer looks sort of like mine, x cubed. Yep, I'm seeing the first answer. I'm looking at his key, by the way. Yeah. However, he goes on to do something. I want to go through that with you because some teachers spend a lot of time on simplifying these guys over here. So let me just go through those stages with you. And you factor top and bottom by x plus 1. I'll put that down for you. What would you go here? 3x squared. The root of x plus 1 plus, this would be x squared, the root of x plus 1. And it seems strange to do that, but it's not a bad thing to do. What do you get at the bottom? 2 times x plus 1. 2 times x plus 1. All right? And then someone says, what would you do with that? There's several things you could do with it. And I'm just kind of looking at his key, and I'm just working through a key. And by the way, looking at this over here, and I'm seeing part of what he's doing, and not exactly mirroring it. I'm doing my work and then looking at his work. And what I'm going to do is I'm going to say I could factor out a root of x plus 1. But you could be all over the page with this one saying, I wonder what one looks best. But let me factor that. What do you get? 3x squared. That doesn't look too bad to me. Then you would get x cubed over 2x plus 1. That's another possibility, by the way. I want to keep massaging it, though, because I do think there's a point in simplifying something. I'm just getting a common denominator there. And yeah, there's a point to it. This would be 2x plus 1. This is the root of x plus 1. What do you get over here? Let's take a look at it. You get, let's see, 6x cubed plus x cubed, 7x cubed. And then you're going to get 6x squared. All right, I'm going to say this is probably the best answer. Again, looking at his key, I'm not saying I see it exactly, but I want to get to his final answer, by the way. And what he does now, he rationalizes the top. And what would you get? X plus 1, 7x cubed, 6x squared. What do you get at the bottom? 2, x plus 1, square root of x plus 1. Cancels these off. What do you get? 7x cubed plus 6x squared over 2 root x plus 1. And that's his final answer, by the way. Again, someone says, which one's the best answer over there? I really can't say which one's the best. All I can say is that if I were taking its derivative, I'd probably leave it there, by the way. I took its derivative. If I had to use the derivative, I probably would have to be careful about that. But if I were to use the derivative, what I would do is I would factor the top. X squared comes out. What he left off with is 7x plus 6. And the bottom would be this over here. Now, as soon as it's used derivative, what does that mean? Really determine its sign, whether it's positive or negative. All right? Okay, so I'm going to say that's 31. Let me just keep going through the sheet and see when it's going to change. I got 32 now. And 32 is this big F. And that's going to be x cubed times the natural log, x plus 1. Well, F prime. Well, let's mix it up a little bit. X cubed times the derivative of the second function, 1 over x plus 1, plus the derivative of the first function, which is 3x squared, times the natural log of x plus 1. So put a little box in that. All right. Now, certainly, is that a good answer? To me, it's a good answer. The only difference in his answer key, he actually takes the first term and writes this down instead. Second term, he doesn't do much with that. All right. Does that really change the problem? No, it's the same thing. All right. So let's keep moving. Let's go to 33. I'm at 12% battery, so I have to get moving here. F of x equals x cubed, x plus 1. He wants to use the product rule, so I have to rewrite this as a product. X cubed times x plus 1 to the minus 1. Nothing wrong with that, by the way. Well, I'm going to take the derivative now, so it's going to be 3x squared. You can mix it up a little bit. X plus 1 to the minus 1. And that's going to be plus x cubed times the second function, which is going to be minus 1 times x plus 1 to the minus 2 times 1. Let me just clean it up a little bit, and that's going to be 3x squared over x plus 1 minus x cubed over x plus 1 squared. If you want to write in terms of one term, which you did, I'll go through that with you, that's fine. Let me go through that with you. X plus 1 squared, that would be 3x squared, x plus 1 minus x cubed. Let's see if we can figure that out. You're going to get 3x cubed minus x cubed, which is 2x cubed, plus 3x squared over x plus 1 squared, which is not a bad answer, by the way. Again, if I were to use that, I'd still factor the top. I'd factor x squared out, and you left off with 2x plus 3 over x plus 1 squared. That's also a fine answer, by the way. This is the answer he has in the key, though. And it's a good idea to really aim for what the key is giving you. And if your teacher gives you a key, aim for their keys. All right? Let's put number 34 down. Got to be real careful with the clock here. This is f of x. Use a lot of different notation for functions, by the way. 3x plus 1. Again, we're using power rule. And oh, I'm sorry, this says quotient rule. We're going to come back to that. All right? We'll do that later. Thank you.